Here we're looking at the integral of tangent squared x times secant x. And this is one of the harder integrals that you'll run into when you're first learning to do trig integrals. So to jump in, what we'll do first is we'll rewrite tangent squared as the integral of secant squared x minus 1 times secant x dx. Then we'll go ahead and FOIL the secant x, and we'll be left with the integral of secant cubed x minus secant x dx. And now what we'll do is we'll go ahead and split this integral into two. So what we'll say is we'll say the integral of secant cubed x dx minus the integral of secant x dx. So first we'll focus on this one because this integral is actually something that most professors have you memorize. What that integrates down to is the natural log of the absolute value of secant x plus tangent x. So now we'll just focus on this one here. And so what we'll redo that one as is we'll rewrite it as the integral of secant squared x times secant x dx. And now we'll perform an integration by parts. And we'll do that first by letting u equal secant x. The derivative of u in that case is secant x tangent x. We'll let dv equal secant squared x, and we'll integrate that to get v equals tangent x. And now, with integration by parts, we'll go across the top and then down over. And so what we'll get is we'll get secant x tangent x minus the integral of secant x tangent squared x dx. And the keen eye of us may notice that secant x tangent squared x is actually the original integrands that we've been working on. And so what we can do is we can come back up to this step here and we can incorporate the two integrals that we just got, and we can rewrite them. So what we've got is this integral here, which represents secant cubed x, and we are going to subtract this one here, which is from secant x. So rewriting all that, what we can do is we can say secant x tangent x minus the integral of secant x tangent squared x dx, all of that minus the natural log of the absolute value of secant x plus tangent x minus the natural log of the absolute value of secant x plus tangent x. And again, because all of these are integrals with no limits or bounds here, what we're going to do is add a constant at the end, just so we don't forget later on. Now remember that this here is the integral that we're working on at the very beginning as well. So what we can do is we can say the integral, the original integrand, I, equals all of this here. And what we'll also do is we'll replace this integral here with I, because it is effectively the same. So what we'll do is we'll rewrite the whole thing. We'll say secant x tangent x minus the stand-in place for I minus the natural log of the absolute value of secant x plus tangent x plus a constant. Now what we'll do is we'll add this I on this side, and we'll add it on this side as well. That gets rid of it over there. So now we've got 2I equals secant x tangent x minus the natural log of the absolute value of secant x plus tangent x plus a constant. And to solve for I, to figure out what our original integral actually equals, we just need to divide this side by 2, divide this side by 2, and our final answer is secant x tangent x minus the natural log of the absolute value of secant x plus tangent x all over 2 plus a constant. And this is our final answer. If you've got any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.